Hello everyone, my name is Veli-Pekka Salo. I work for a company called Wapice. We are a Finnish software company doing software solutions for mainly industrial companies in Finland and in Europe. And we've been founded in '99 in Vaasa, but actually at the moment we have offices in all major Finnish cities, and we are about 350 experts. And we have also other solutions. We have IoT solutions, sales digitalization solutions, and solutions for following the managing energy consumption, and also a quite big AI team at the moment. So today I will talk about Rust, one of the most admired programming language at the moment. And why I want to talk about it is because we think that Rust and OPC UA could be a nice combination in future. So here's a survey from 2023 from Stack Overflow, and it's actually listing the most admired and most desired programming languages. So desired is actually the languages that people would like to, or the engineers would like to use for programming. And admired is simply those who want to continue using those. So Rust is 7 years in a row one of the most admired. So those who get familiar with the Rust, they want to continue using it. And at Wapice, we are still gaining speed. So we have had internal hackathons, we have had thesis done, and we have even internal training material and a Wapice certificate for Rust programmers. And a team of Rust developers is increasing. And I actually talked with one of our project managers who is working with Rust team and Rust projects, and he mentioned that he has a constant queue to the Rust projects. So there's a lot of engineers would like to use Rust also in Wapice. A background. So Rust was developed as a fast and memory-safe alternative to C and C++. And it started 2006 as a personal project by Graydon Hoare in Mozilla Research. And there's actually a story going on that Graydon was 2006. He was coming back from work to home. And unfortunately, his elevator had crashed due to the software problems. So he had to walk 21 stairs up. And he got quite annoyed and started actually working with something more reliable software platform. And that's the foundations for the Rust. And then Mozilla started to back up the Rust project and 2009. And then finally the first stable release was 2015. So Rust is still quite recent language. And one of the reasons for the popularity is the way how the Rust manages the memory. So Rust is cross-platform, it's fast, it can control over how memory is used, but it's still completely memory safe. So those are exactly the features of C and C++. You can control little details, how you use the memory, how you use the internals of the computer. But then you need to be very, very careful. With Rust, you are more safe. Oh, it's mentioning I should take a break. Yeah. Rust is also thread safe. It has rich type system. It has a very strict compiler, which is actually doing the debugging at compile time. It has some other nice features like integrated package management, good IDEs, documentation, community, and so on. And Rust is nowadays already used in quite many places and in quite big companies also. So there's a Rust Foundation, members are shown in the right. And there's, for example, Amazon Web Services is using Rust, Facebook, Dropbox, Cloudflare, Coursera, Discovery. And Rust is used even for some of the internals in Linux. And then why is Rust needed then? So Microsoft estimates that 70% of vulnerabilities reported for them are caused by memory issue. And even though security and safety is nowadays more important than ever, still the number of CVEs is growing. You can see that it's growing constantly. And we need other methods also to prevent the number of vulnerabilities. So, of course, there's different kind of static analysis tools, and you can use fuzzy testing, you can use taint analysis, you have coding guidelines, you have code reviews, you have training, threat modeling, guidances, and so on. But still kind of the way how programming language can help here is important. And when I took a look at the Mitre database for CVEs, there was these top CVEs. So there's always this out of bounds write, use after free, out of bounds read, and null pointer reference. So those things come over and over again. And we could actually take a small demo. So here's a piece of C code. And what it does, it simply gets some input data from the keyboard and writes it into the buffer. And the biggest problem in this code is here. So it gets the data into the buffer, but it doesn't check the length of the data. And then, unfortunately, there's a variable is authenticated just after the buffer. So that is a vulnerable function, and this is authenticated is used somewhere later in the code to check if we are if we have valid authentication or not. So let's see what happens. So here's a C compiler. So we run the overflow example, and the buffer is able to receive a short string. So that fits nicely into the buffer, and we are still safe. Okay, but let's run a longer. So we write, hello OPC Day Finland. And let's see what happens. So unfortunately now, end of the string does not fit into the buffer. So this is authenticated is now breached, and we are not safe anymore. So maybe simplest possible of example what a buffer overflow could cause. So then, how Rust prevents exploiting coding errors? So it has this quite strict ownership and borrowing, lifetimes, no null pointer, and bounds checking. So basically, Rust has no garbage collector, which runs regularly to look for code that is no longer used, or memory that is no longer used. So there's a set of rules that are checked at compile time. So each value in Rust has an owner, and there can be only one owner to a piece of data at a time. And for these reasons, there's no need to allocate or free the memory. So when the owner goes out of scope, the value will be dropped. So it's different compared to the C or C++, where if you call the malloc or calloc and you allocate the memory, then you have to be really careful to deallocate it also. But Rust takes care of that automatically and prevents from the memory leaks. Then there's a borrowing. So there's immutable borrowing and mutable borrowing. So basically, Rust ensures that if you provide data, for example, to a function, so it's strict if you can change the data or if you cannot change the data. And it checks that at the compile time. So you can separate the code that is intended only to read the data and code that modifies the data. And this is actually really good for preventing the data races in multi-threaded applications. So Tony Hawk called it not a million, but $1 billion mistake, invention of the null pointer. 1965, developer of alcohol. And in C or C++, the null pointer is a pointer that does not point to a valid. And unfortunately, these null pointers, they are often quite good entry points, or crashing using the null pointers are often quite good entry points to exploit vulnerabilities. So you try to trigger an exception, you get a crash, and then you maybe reveal some debugging information, and you understand the program logic. And then you know how to plan the next attacks, so you find the vulnerable places. And Rust enforces this safe use of none through option enum. So it doesn't have a null pointer, but it has the safe use of none. And then there's, of course, this bounds checking in arrays and slices. So slice is basically a reference to a certain piece of data in a buffer. So Rust has mechanism how to refer to that data and how to use it safely. So it's immutable by default. So you need to require explicit declaration if you want to change the variable. It's type safe. There's no null pointers. It's safe concurrent use of data. There's no dangling pointers, no buffer overflows. And then there's distinction of safe and unsafe code. So if you really want to control the code, then you need to define it specifically. This is unsafe, and now I want to control it myself. Here are some other Rust features. So unfortunately, Rust is also a little bit more complicated. So there was a Rust survey from the Rust language blog. And one of the reasons that Rust or the programmer stopped using Rust was that it was too difficult to learn. Okay, there were still factors outside my control, and I prefer to use other languages. Those were equally high. But then why did you stop using Rust? Too difficult to learn. I prefer to use another language and factors outside my control. So it's still, there's a steep curve in learning Rust. But still, when you make the first hurdles, then it pays off. So then about Rust and OPC UA. So it's still a bit small. So there is an open source implementation for OPC UA by Adam Locke. You can find it from the GitHub. and it's OPC UA server client implementation. And it has all the basics you need. So it's provides about the OPC UA embedded profile, which allows basically binary communication, encryption, user identities, subscriptions and monitored items and events. And there's tutorials available, both for client and server, and even some tutorials for the cross-compiling if you want to use it for some restricted device. There's quite good examples. You can find server and client examples. You can find a more complex server that you can use for compliance testing even. And then a couple of more examples. And if you look at the OPC UA server features, it actually has quite good support, but not everything. So our experiences so far, they are positive at Wapice. So you are able to create a product with limited set of features in OPC UA using Rust already. And the client, so one thing is that client API is synchronous at the moment. So that was one thing in the to-do list, that they want to increase the asynchronous part. On the other hand, under the hood, it is already asynchronous. So things are getting forward. And most of the features that are implemented in server side, you can find the counterparts already in the clients. So you can look at the server services, and you should find those that are analogy for those in the client side also. You have the encryption stuff, message security modes, sign and encrypt, security policies. There's even the more secure versions are available. User identities you can use, and you have the crypto library. The OpenSSL is used as a crypto. That's maybe still something which is external to Rust, and it's implemented in C at the moment. So it adds a little bit complexity. And here's some future work that will be done in Rust somewhere soonish. And as a conclusion, so why we think is Rust and OPC UA could be a nice combination in future. So I'm not saying that you should now throw away everything you have and change to Rust, but this is maybe just to raise awareness that, okay, Rust is there, it's really interesting. And what is nice in OPC UA is that it brings the cybersecurity in the device communication. So you have the application layer security, you have the communication layer security, and then you have the transport layer security. But if you cannot trust the foundations, can you trust these? And by foundations, I mean the source code itself. So with Rust, you can have it even more secure. So you can have also some of the worst memory problems and vulnerabilities. You can override those and have it even more secure. So that was it. Thank you. Any questions?
Thank you.